So very good morning, students. This is already we seen the DCS and SCADA. So now we are going to discuss about the human machine interface. So now we can see the diagram of the schematic diagram of the human interface system for the water heater process. Here we are having process. We can find out the process. So once the water is came into the tank, so with the help of the valve, we are going to control the water. This side we are having the energy meter, circuit breaker. To switch on or switch off circuit breaker, we need the energy meter. Okay. So what happens here also we are providing switch, here also providing switch. This is automatic, this is a manual switch. Sometimes what happens we are also having we can make a program, and the program, depending upon the program, the system is going to be intelligent. But unfortunately, if anything is happened, we are having the provision to control. That means to switch on or switch off the valve, or to switch on or switch off the breakers. Okay. So here, as I already said, we have to monitor the water, and to allow the water in the water tank. We are having the provision to switch on or switch off the wall of the water incoming to the tank, and finally we are also having the provision to switch on or to energize or de-energize the circuit breaker by using the switch. Okay. So once the water is filled, what happens? The water is started to heat. Once the temperature is reached, the circuit breaker switched off, and finally the valve is also closed off simultaneously, and the water out comes out. Okay. So in both the sides we can find out what's actual water consumption is happened in the tank, consumed in the tank. This side we can able to find out what's the energy taken for by the stirrer to heat the water, okay, using circuit breaker. So we can able to find the two actual water consumption is there, actual energy consumption is there. Okay. So here the operator panel is integrated with the controller through I/O modules for human interface. Generally this is a front end. Okay, you can see the front end. As this is a front end, human machine interface is there. Again the back end, what happens? So many sensors and actuators are interconnected with the real-time systems through I/O modules, that is input-output modules, and through input-output data are transferred to the corresponding display terminals. Going to back end, if you give the signal, if you switch off, so manually you are going to open the valve. Once you open the valve, immediately the signal will have to transfer to the real-time system through the I/O modules. So here we can see that information is displayed on lamps and meters. So this is a meter. So we can find out what's actual power consumed, actual energy taken by circuit breaker to heat the water. This side coming to how much water is flowed in the tank. This is what we can say meters. If in parallel we are having the lamps also to indicate whether it's in the proper system is in proper condition or not. Okay. Its proper condition or means whether the system is properly working or not. If anything goes beyond the limit, the alarms, that means the lamps will start to indicate. Sometimes alarms also there. We come into manual control is from switches and potentiometers. So automatically, most of the systems coming in intelligent systems, the process control automation. If you going, sometimes if you find any hazardous things, as the operator is having the rights to control the systems, or to taken care by the system taken care by the operators. Yeah, the human interface functions are achieved to programming controller. Okay. So what I said, this front end and back end will be interconnected with the help of some I/O modules with the proper programming. Okay, that's why the human interface is needed to transfer the data from here. Whatever the operator needed to transfer the data to the real-time system, and for that, what happens? Controller is needed. Okay, actually, if you're going to traditional operator panels actually simple and less expensive, but not intelligent. Traditional expensive panel means yes. Conventional days we having the panels like this. We manually have to switch on or switch off each in every system. It's very difficult process, tedious process, and each time we cannot have the awareness as a human operator. If anything, if human operator feels fatigue means, and if you're not able to control system, the entire process is going to be a hazardous condition. So what happens? The traditional operator panels since is simple and less expensive, but not intelligent. Not intelligent means if anything goes beyond the limit, the system will taken care by the system will taken care to control the process. But here, if we leave it, unfortunately, the careless mistake, if you leave anything, what happens? The entire system is going to spoil. Okay. And I know and similarly, if you come into the traditional operator panels, we having no provision to store the data or to exchange the data from one mode to another mode. Okay. So here what happens, we can store the data and we can retrieve the data whenever we need it, and is having the possibility to change the data from here to there. That's the thing we already studied in the DCS and SCADA. So once the RTU is in different location and standalone control is in different location, we can transfer the data as quick as possible from RTU to the standalone processor. Okay, that's the thing you're saying. Traditional operator panels which are simple and less expensive but not intelligent. It's not intelligent system. And finally, you're not having the provision to retrieve the data or to exchange the data with this process with this control to another processor. And And what's happening? Yes, the electronic signals are transferred through the I/O modules to the backend. That means to the real-time system. On the real-time system, the data are transferred to the HMI machine interface through the I/O subsystems. Okay. So if we come into the next category, need to input other information into the controller, such as date and time, so that events in the processes, alarms, measurements, control, and actions, extra are recorded and stored within the time tags on a real-time basis. That means it need to input other information. So sometimes it takes some other information from the controller, such as date and time. For example, with respect to this time, the temperature is 30 degrees centigrade. With respect to this second, the temperature 30 degrees centigrade. We can able to monitor the entire process with respect to the date and time. Okay, as like a line format. That means we can say there's a line format in the industry. Okay, so what happens? Let's put a date and this time, and what happens? And this atmosphere. We can. This is the temperature. This is a water level flowed into tank. As like that, we can monitor all the things in the entire processes. That's called as events in the process. Okay. So what are the events happening in the process? Is having the provision to record all the things. Okay, in the human machine interface in the intelligent systems, not in the traditional operator panels. Okay, so what happens? That's the thing we are saying. Need to input from other information control such as date and time, so that events in the processes, alarms, measurements, control actions, extra are recorded and stored with the time tags on a real-time basis. So each and every time we have to take care of the data, and the data have to be stored and recorded for further analysis when things happen beyond the limits. Okay, so in the traditional operator panel we are not having the provision like that. So if we can monitor it, and if we find out if anything goes beyond the limits or within the limit, we are having the provision to operate the switch or any other switch-based systems or some other graphic-based systems, but we are not having the provision to record the data, and we are not having the provision to record the data. So let's put the event process such as date, time, and other alarms also. Okay, that's possible in the intelligent systems. So generally, human interface systems are totally software-based and work with the latest graphical user interface techniques. That's called as operator stations. We can say that a human interface technique is an operatory interface with the system that is called, the entire setup is called as operator stations. Okay, so actually the operator stations initially it is initiated with the monochrome alphanumerical display terminals. Alphanumerical display. If you take in the CNC, what happens in the conventional days, we make a program the punched tape and punched card. But if we come into here, what happens? We have in the desktop, we can find out the typewriting machine as like that. We have one operator systems, and we also operate the station. Okay, so here we can find out if you make a program, we can make a display. Here we can, what are the things what is happening, you can take as a, we can find out as a print display. It's also display, but it's a form of printed format. Here it's a form of the viewing format. Okay, so it's a monochrome alphanumeric display terminals. That alphanumerical display terminals, it's a form of the numerical formats. Okay, for example, A10, B20, C30, as like that, it comes like a alphanumeric display terminals in the printer or in the desktop. Okay, this is the conventional operator panels. Coming to here, what happens? Operator performs the following sequence of interactions with the control through the alphanumeric display printed terminals. Display of printed terminals. What are operators can able to perform the function is operator sends a query. First, operator sends a query, and what happens through keyboard? The operator receives that. So, what are the queries sent by the operator through keyboard? It processes the query, and operator receives the echoes of query by displaying or printing into the terminal. Okay, what are the queries you raised? It will be displayed, or it will be floated in the display. Okay. After that, once it's floated, we have to take it again. The controller have to accept the query and process the query. That's the most important thing. So controller accepts the query, and if it is valid, the query will be processed. That's the most important thing. What are the queries raised by you as operator? Okay, the controller wants to process the query, and the query is valid. Okay, and it will start us to process the query with the help of the displays and the printers. Okay, so once the query is processed, it gives the final output in the form of text message or in the form of video, in the means through display or printing on the terminal. That's the alphanumeric display terminals. Most important thing is alphanumeric display terminals. Here you can find out the text message or alphanumeric message in the form of the display or the printing on the terminals. And what's most important thing is whatever the query has raised by the operator, it sends to the controller, and the controller want to process that. Controller will process, and the query is valid means it processes the query and gives takes the action as per the queries. Okay. So this is the operations performed by the operator in the alphanumeric terminals. Okay. That's a limited process. Next, interactive terminals being only alphanumeric does not support any graphics. Since we have said graphical user interface card, here we are not having any graphical user interface systems. We have to arise the query, and depending upon the query, the controller starts to process the query, and gives the valuable things with respect to query in the display. We can process, we can view it, we can take a printout, we can find out in the display, but it's not possible to monitor it, to edit it, to monitor it as when combined intelligent systems. Okay, that's the thing we are saying. Interactive terminals being only alphanumeric does not support any graphics. We cannot find any alarms like that, any switches like that, manual switches as like that. Okay, any lamps like that, any alarms as like that. We cannot find any meters also. Okay, it's a display. We can find it. We can print it. That's all. Okay, so these terminals are communicable. This terms are communicable, but does not having any intelligence. Does not having any. If I want to control systems by manually, it's not possible. It's not possible. It's very difficult. Okay, that is the intelligence systems. So and does not having any built-in intelligence. That's the thing we say. Intelligence is missing. And probably yes, the same thing. What happens? The I/O modules are there to transfer the data from the display terminal, printer terminal, alphanumeric terminals to the processes, and from that process again the data is transferred to this processes. Okay, so what happens since the monochromic alphanumeric display terminals, it takes some more time. Okay, if we take the CNC, the punched cards, if we make a program with punched cards, what happens? It takes the controller reads each and every line, and then after reading each and every line, the controller will fit the sequence of the function. After that, it starts to proceed with the CNC machine. As like the same thing, okay, what are the button done by you? It starts to process the first sequential thing. After that, it starts to work with the processor station. It's very difficult. That means it's possible. It takes some more time. And if you want to edit it, means it's not feasible. It's not possible. Again, you take some more time to edit it to fix a new program. So to replace the traditional operator panels, you're going for intelligent operator panels. This is advanced technology, and we having a inbuilt intelligent system is there, including instead of the alphanumerical display terminals, we having entire graphical user interface systems. If you take LabVIEW, we having the front panel and the block diagram. Okay, so whatever the icons you need, you can take the icons and can fit it in the front panel, and we control the panel. If we can switch on or switch off, we can find out how the process is going on in the block diagram, in the LabVIEW. The same process like that. So that's advanced human interface systems are processor based, and built intelligence system also built intelligence capability is also there. Instead of alphanumerical display terminal, that's most important. Okay, we are not having any programming based systems. We are graphical user based systems, and it's customized as per the requirement of the operator. So, sir, I want to track the turbine 1. So I am having turbine 5. I want to track the turbine icon, and I want to rename this turbine 1, 2, 3, 4, 5 in the graphical user interface. Yes, it's possible. Okay, if we go into the alphanumeric display terminals, if I give the name is first turbine is 1, 2, 3, second turbine is 3, 4, 5, third turbine is 5, 6, 1, means as a common operator he can understand what's happening there. If the operator is changed, he cannot able to, sometimes even though it's well practiced for him, sometimes what happens, there's a chance for errors. So here there's alphanumerical display terminals are there. Okay, but here if you go into the graphical, if you want a turbine, you can take the turbine icon and you can name that as turbine 1, turbine 2, turbine 3, turbine 4. So what happens in that's a graphical interface icon, and probably give the name as per your requirement. It's easy to control, it's easy to diagnostic where the problem is happening, and also easy to as operator to identify the each and every processes. So that's the thing you're saying. Advanced network systems are intelligent, customize the terminal, program displays, and key functions for specific requirements. You can customize as per your needs, as per your programs. Okay, I'm having 5 processes, and the 5 processes I'm having around 20 sub processes. Yes, we can customize. We can make a flow chart. We can make a human machine interface. Okay, you can make a process diagram. You can make a flow diagram, and you can, what are the icons you needed, what are the processes, what are the sub-process involved in each and every process. You can take the icons and put it and integrate it properly, each and every sub-processes, and each and every sub-process integrate to the processes, and we can monitor the systems. It's very easy and reliable when compared to traditional operator panels. And also nowadays modern operator panels are equipped with serial interface to communicate with controller. What I said in the DC and SCADA, once the remote terminal unit is adopted with the real-time system in India or in Bangalore, and again another remote terminal unit is interfaced with the real-time systems in unit in Kolkata. So is it possible to transfer data from Calcutta and Bangalore to the standalone control system which is located in Bangalore? Yes, it is possible. Okay, that's possible. Okay, so if we take we can find out our Coca-Cola company. So we having a number of companies in different regions of the country. So one system is monitored in one. That means if you take if you go into Kolkata new plant is that the entire process is monitored and relying on remote terminal unit. The remote terminal unit will record all the things and transfer the data to the standalone controller which is located in the Chennai. Okay, one more plant is in Delhi. So what are the process happening in that processes? It's also transferred to the standard control which is located in Chennai. Okay, so we can monitor the process from standard control. That's the thing you say. Advanced technology is called as a serial interface, either Ethernet interface. We can communicate the data. What are the data is processed? What are the data? And same time, data is also recording in the drives. And same time, the data is also transferred to the real-time controllers, standalone controllers. So you take the example, we are having the camera in each and every room. Okay, so what happens, we can control we can monitor if you're going outside, you know what's happening in the house. Okay, what happened, the camera switched on already, the camera start to record all the things and destroy, and the cameras recorded and database also stored in the drives. And similarly, okay, you can actuate the drives and you can find out at this time what's happened in my house through your mobile. That's you are in around 40 kilometers from here. Okay, so that type of modern panels, that's also not the modern operator panels. Okay, so that type of feasibility is there nowadays in the current scenario to transfer data with respect to communication side. So here what happens, your monochrome alphanumeric displays is also there, but function numeric key is also there. Most probably what happens in the modern operator panel, intelligent operator panel, we try to most of the operators are avoiding the monochrome alphanumeric panel since it's a traditional panel, so it's very difficult to fit the program. So we are going to function numeric panels, and that means we are using graphical interface card, we're tracking the icons and put in the program and easy integrate all the things and start to control the process. Okay, so it's one of the small operator panels. What happens here, you can fix the left side arrow and right side arrow to fix the limits. Okay, it's a text display, it shows that what's happening here. And this is this icon is okay, this is taken care by we to fit one limit. For example, water limit, water flow in, water flow out limit, circuit breaker on limit, circuit breaker off limit. Okay, and finally you can fix the also having up and down arrows, left and right arrows. Okay, to fix the limits. Okay, so this is the more advantages of the human operator human machine interface panel, that is a advanced level panels. Okay, here also we can use monochrome LCD screen instead of the conventional day screen. It's very difficult to monitor process, and also it gives the problem to the eyesight for the operators. But if you're going to use LCD display screen, monochrome LCD display screen, and second thing is we can find out the lines. In the lines, what happens, XBT indicates some other parameters, N40 indicates some other parameters. Okay, as like that you can able to monitor, but since it is not a graphical user interface, it's a text display thing. What I'm saying is it's a alphanumeric terminals. Since it's alphanumeric terminals, okay, and it's also LCD display, we can monitor with respect to line. Each and every line indicates the different process in the process station. Okay, and finally we have also keys. Here what they're saying is 7 operator keys are there. So 4, 5, 6, 7. Okay, 7 operators keys are there to customize the process as per your requirements. And finally we are having the serial programming interfacing also to transfer the data from here to the corresponding location to stand. That means wherever you need it. And parallelly, this is also operated with the MS Windows based. It's not a DOS prompt and it's not command prompt. It is a user feature. Since you're going for graphical user interface, it is a MS Windows based software for configuration. It's very easy for you to make a program. So in olden days, what happens, you have to make a program, it's very difficult. Okay? You have to make each and every line, you can convert into each and every line indicates the alphanumeric terminals. For example, 0 indicates and this valve off, 0 indicates valve on. Okay, as like that, we have to name the each and every processes, and you have to include that name in each and every line. It's a very difficult process to find out where the problems happen. But if you're going to a graphical user interface, you can track the icon and you can put it in the operator panel. panel, and if anything is happened, it shows the alarm in the graphical icon. It says that the problem is happening turbine 1, turbine 2, turbine 3, turbine 4. Okay, you can find out easily you can troubleshoot the problem as quick as possible when comparing to the conventional operator panels. If you come into operator stations, so nowadays what happens, most of stations with a graphical user interface system with high resolution full graphic displays. So if you come into recent scenarios, operators cannot work having the feasibility to work with the alphanumerical terminals. Okay, that's like what I said. Alphanumerical terminals is like a programming each and every line. It's very difficult using the function numeric keys. Nowadays, what having graphical user interface keys, user interface is there. So in the graphical user interface, we can find out high resolution and data with the full graphical displays. And it's very easy to troubleshoot the problem, as I already said in the previous slide. And what happens? In operator interaction, the process shifted from keyboard or coded text message to display to keyboard mouse. That's the thing I said. The coding, okay, DOS prompt coding or coded prompt will be removed, and it's a graphical user interface using a keyboard and mouse. With the help of these two components, we can control the entire processors and can fix the limits, and you can monitor the process, and entire things will be operated with these two things instead of going for command prompt. We're going for command prompt, okay, using the alphanumeric terminals. That's how opened by here. For example, if you take the first, we will take a regular example of water heating process. Here, what happens? Valve have to open, valve breaker have to be opened or closed. Okay. The valve gets open to allow the water inside in the tank. What happens? Whenever the water level in the tank goes below the desired level. Okay. So we are having limit switch. When the water level goes below the tank, automatically the valve will be open and the water is allowed to enter into the tank. Once the water is filled, once the water level is reached, again what happens? The valve will be closed. So otherwise, no action. As like that saying. Okay, the valve will be opened or closed. Respect to the signals what is it from the corresponding limit switches or breaker switches. Okay, so the water and power consumption is going to be controlled here. Okay, it's going to be compared to the respect to operator stations. So we can already, I said, we are in 3 substations: operator substation, controller substation, and instrumentation subsystems. Okay. The instrumentation subsystem will transfer the data from the real process to the operator station, that's to the human machine interface to the controller substation. Okay. So we are having different control substations, different modules to transfer the data from operator station to instrumentation subsystems. Using the keyboard and mouse itself, we can control, we can monitor the process, we can make a graphical user interface for this process, and we can monitor it. Okay. And probably since we made a program already, it switch on or switch off the water allowing cold water valve automatically. And if we find out, sir, I want to raise the limit of the water level, so I want to raise the limit of the water level in the tank. Once I'm already fixed this, for example, 5 ml water, I want to fix once the water is reached 20 ml only, the water valve have to be closed. Yes, it's possible. Okay. So if you purchase if you go into regular water heater process in our domestic appliances, so we have purchased 20 liters of water. Okay. Once the water is reached around 8 liters, automatically what happens? The water valve will be closed and the water will not comes to the water tank. And probably once if it's in this side, simultaneous in this similar side, if you switch on the heater, the water goes to heater to certain temperature. Once the temperature reaches, automatically the circuit breaker will be stopped. Okay, so as like that, what happens? We are using the ready-made defined operations. In 20 liters water, I want to increase the 18 liter of limit to 19 liter of limit. Is it possible? It's possible, but we have to rechange the program. Okay, we have to change the coding in the program. It's an inbuilt thing. Okay, so we are not having intelligent systems here. So what I can do? Then you can go for the small operator panel with the mobile. Okay, with the mobile. That's human machine interface. So I can fix the limits. So currently I'm having 18 liters of water is a limit for me. Why not I can go for 19 liters of water? Yes, it's possible. Okay, so that type of systems we have to design. Okay, so what are the systems coming for the domestic ready-made system? Is it possible to increase the limits, or is it possible to tune the systems as per our requirements? It's not possible. It's possible. Yes, it's possible, sir. We have to interface your IO modules with their with your real-time process. For example, your mobile here is real-time process here. The operator panel is a mobile with the real-time process a heater. So I want to increase the 8 liter of water from 8 liters of water, okay, from that limit to 9 liters of water to the new limit. Yes, it's possible. So since operator panel is here in mobile, we can fix the limit. The graphical user interface display automatically the water limit is increased to 90 centigrade. Then yes, we can save the energy. Okay, as like that. Okay, why not? So you are going to somewhere. Okay, you are in your native, so, and probably you are working in location somewhere. I want to monitor what's happening there. It's possible. I want to switch on whether you're going in train. You don't know whether you switch on or switch off the AC. So with the mobile, you can cut off the AC or switch on the AC. Yes, it's possible. So that is a miniature operator panel. This mobile is a miniature operator panel taking care to control the systems which is in your home, which is in house, okay, through the Ethernet communication or through serial communication port. So for that, if you're giving the data in the operator panel, what happens? The data have to transfer to the real-time process. How the data is transferred? So you're entering the data, data stored in the corresponding mobile. In the meantime, phones also want to transfer the data to the corresponding home application process. Okay, for that we need the serial Ethernet connection or internet connections. Okay, yeah. Coming next line, operator station is country to control over an Ethernet communication interface. That's the thing I said. So the plant is somewhere located around 20 kilometers. I want to control the process from here. Means yes, it's possible through the serial communication. No sir, my plant is located around 1000 kilometers. It's possible. Yes, through Ethernet communication is possible. Through a wide area network, LAN area network. I already discussed the TCS and SCADA. So this is you can find out the graphical user interface of the water heater process. You can find out the actual design. Sir, as I already said, I want to change the limit. Is it possible? Yes, actually limit is 10. Design limit is 15. Okay, I want to, if I increase the limit 10 to 30, 12. Yes, it's possible. But if it is going to the conventional plan, it's not possible. It's not possible. Okay, if you're coming into here, how can you? If you're coming into here, on-off breaker. Okay, so what happens if more number of water is there? Again, what happens? It takes some more time to heat. If it's possible, so I want to change the actual value. Okay, actual desired temperature. Yes, it's possible. Change it. Desired means you have to fix the limit. Okay, so what happens? I want to increase the level of from 15 to 16. This is the tank capacity is around 20 m. For example, it's 20 ml capacity, 20 ml of water capacity. I want to increase from 15 ml to 18 ml. We can change it here. Okay, you can change it here in the graphical user interface. If you change it here, immediately what happens? The temperature of the water also setting time also have to be increased. Then only the energy can we have to minimize energy consumption. Okay. So what happens? So you plan to increase the desired temperature also. Yes, it's possible. Okay, once the temperature reaches, once the process is over, okay, water is coming inside and heating element is start to heat the water. Okay, once the temperature reaches, automatically what happens? The system already make a program. That means once the corresponding limit reaches, it switches off the valve. It switches off the entire systems. Okay, so once the water level in the content comes reduced, automatically the valves will be open. If the valve is not open, we are having the provision to open the valve manually. That's the thing we are saying. It's a real-time display process to monitor the actual and desired value of the water and the energy consumption, and probably having the right to switch on or switch off the breaker and switch on or switch off the valves. This is we can monitor the real-time process. What's happening here? What's happening here? What's happening here? What's happening here? If I want to modify, yes, you have the right to modify, okay, as per your customized process. Second thing, if anything is not possible, so if we find out the system is not taken care to control the process, so as a manual operator, we enter into the state and we having the rights to change the progress, to change the limits, or to taken having the rights to taken care of the process by you. So generally, if you come into the basic components, we having passive and active components on the display screen. Okay, so here display screen layout, active display elements and active control elements. So what I said here, the display screen layout is that means it's inactive. Okay, it's in display screen. This is the display screen layout. Okay, so here you can find out the water layout is there, the temperature layout is there, and on off valve is there. That's like that we can find out the process layout. That's the thing we are saying, that display process screen layout. All the process layout are fed in the display screen layout. Okay, Like that means all the process layouts, each and every process are embedded in the display screen. If we come into active display elements, you can find out that so many bars. That means that's a process that display screen means this is a line diagram for each and every processes. In that every process, we are fixing the limits. For example, we are having the blocks, we are having the blocks, we are having the icons, we are having the icons, upward icon, downward icons. Okay, so these blocks will be taken care by the active display elements. Okay, so I want to fix the limits in the box. So using the upward and downward arrows. Yes, that is called as the controlling buttons on the screen to open or close the wall, or break. Okay, so up and down arrows are there. Okay. The entire line diagram of the process taken care by the display screen layout. We coming to active display elements, each and every blocks, the corresponding, and this is a block. In that block, we are having two of these blocks. Okay, so each and every blocks to activate the taking care or designed to activate the process. That's called as the active display elements. And parallelly, active control elements means we are having the controllers. On of control, depending upon the signal what we got from that water to the display box. That is called as active control elements. So coming to controlling, we are having the different direct interaction process and indirect interaction process. If we come into display, we cannot find out any times and any IDs or any other state level functions. But here coming to this the direct interaction, we can find out the date, month, and the corresponding time, the date, month, and year, and corresponding time. Okay, that's it. Okay, so direct interaction. We can find out that means, for example, I want to modify it. I want to fix the limit as per my recommendation. Yes, it's possible. So we have to identify. I want to fix the temperature. I want to change the temperature. So we have to click it here, left click, and left. Once you click it here, what happens? The block will be open. You have the rights to modify the block, and if you fix the left side or right side arrow, you can having the rights to fix the limit. Okay, that's the thing we're saying. First you have to identify which object you have to change the limits, or you're going to fix the value. Okay, so you have to fix the cursor and you have to click it. Once you click it, that means left click it. Once you click it, the object will be selected. Once object is selected, if you click the right click, what happens? You can having the rights to modify the limits, to modify the setting parameters. Okay, so here what happens once the temperature limit is reached to the extent to corresponding from the corresponding limit, so its temperature limit is exceeded. Audible alarm not enabled. You can find out. Okay. So what happens here? The temperature limit is exceeded. Alarm have to be indicated. The alarm is not indicated. Then as operator, we can say that our temperature limit is exceeded. So we have to switch on the alarm. For example, I am saying here, what's the graph in schematic indicates? Alarm limit is exceeded. Temperature limit is exceeded. So alarm have to be alarmed, but it's not alarmed, so you have to enable the alarm. In the meantime, how you are going to select it? So what are the activities you have to change it? Try to select the block, and once by left click and right click, and again once after left click, go to place a cursor on the same block and right click the cursor. Okay, we can find out the setting parameters. We can have the right to tune the parameters as per your requirements. That's the thing is in direct interaction. Display of process wall states and control of process wall alleged states. Okay, so we can find out the display and control. Okay, the display is there and operators observing and intelligence, and we also pre-programmed. Once this process working properly, not a problem. It's not working properly. This controller system control automatically taken care to control the process. Since it's not working properly, what happens as operator? You have to take care of the control of process or states. We come into the second interaction, navigated interaction. What's a navigated interaction? So here we are having, since it is a human machine interface, we are having certain limits. So we have some certain displays, certain active display elements are there. Okay, we are having display elements, but we are having limited display elements. But if we are going to here, we are having n number limited displays for each and every units. For example, you can find out the walls. In that wall, open, execute or cancel. Okay, so that means so many subprocessors are happened in this. So many sub-active display elements are there. Here, only one display element, so switch on, switch off. Sir, I want to change the temperature here. Yes, left click. Once left click the object, right click again. You go for right click. We can. What happens? We having the rights to fix the limits by pull this arrow upward or downwards. Okay, but here the same thing is that if you come into your on off wall, we having says that on or off. But if you go into here, I want to open the wall or execute the wall. Okay, active, one more active display elements. Another control action. Okay, so all the active display elements comes to picture. All the active elements comes to picture, and they are having the rights to modify the limits, and they are having the rights to execute the process as per your requirements. One system is not working properly, that's most important thing. So already it's pre-programmed, the system start to work as per the pre-programmed. That means pre-programmed is inbuilt intelligence. Since it's sometimes it goes beyond the limits, we are having the rights to interact with the operator, having the right to interact with the process and taking the process to its level, taking the process to its control. Okay, that's the thing I'm saying. The same steps what if followed for in direct interaction, you have to follow for the navigate interaction. Here what happens, for each and everything, additional active display elements are there. Okay, additional active display elements are there. If you're going to limit, increase or decrease. If it's increased, then I want to execute or cancel. Okay, that's like that. Additional active display elements coming into the picture, and that is called as a navigated interaction. Okay. See what I said. The active display elements, second active display elements, third active display elements. Okay. So display menu in that, whether event open command, close command, event display, alarm display, what display you needed. For example, if you want to make a program, if you make a graphical user interface in the operator mode. Okay. So display menu, whether it's it should be a event display like this, or it should be alarm display. What type of display you need, or it should be a somewhat command have to become. See, it's command. It's a somewhat symbol display or alarm display or command display. Command means this is a command display. So now I want to close the command. Yes, go to, I want to open the command. Open the command. Open the command means execute. Then you have to type it. What is the name you're going to give it here? For example, this is a turbine one. Okay, I am tracking this icon from this my database, and putting the icon here, and I give the name as turbine one. For turbine one, I want to go for display menu on an open command. In the open command, execute. Execute means automatically will come such a box. And after that, you have to type it turbine one. Okay, as like that, whatever the interactions you needed with the active display elements, it's possible in the navigated interaction in compiling to the direct interaction. Direct interaction means it's there, but you're not having the number of active display elements in this human machine interface process. But if you're going to navigate interaction, we're having more number of human machine interface elements, active display elements, and it's very easy to control the process. Okay, yeah, as operator, you can having the rights to, you can customize the process as per requirements. Here it's not possible. You can customize, but it's having certain limits. Here, whatever the needs, whatever names you have to give it. Okay, whatever the commands you have to give it. Yes, it's possible. In the more number of active display elements, as I already said, see main level, second level. If you need 5 more levels also going to be, if you go into real time process, so many levels will be there. It goes to around 10 levels, 20 levels. Okay, depending upon the number of parameters. You can find the display for electrical substations. What happens? An active element is there. Okay, so you can find the symbol. In the active element, we are having the command prompt, open command prompt. Okay, go into second. Yes, for second second symbol, second process, or second system, second process, next process, you have to open the command. Okay, this active display term, You go into this circuit breaker. This is a what I said, navigate interaction, active display terminal. Okay, if you take the process, we have so many active display terminals. Here, if you go into previous processors, direct interaction, we can find a limited active display terminals. For example, you are having on block, you are having on block. That's all. Okay, but if you go in here, see how many blocks are there. Block 1, block 2. That means what I said, active display elements 1, 2, 3, 4, 5, 6. That's like that. A serial number of active blocks are there. Okay. So that's most important. Okay. That means it you having the rights to custom your process. You having the rights to frame your human machine interface as per your customized process. So this is a display which is designed for the electrical substation. Yes. So, navigate the command execution. As I said, it's continuous now. This navigated interaction. So going to the sub blocks, secondary levels, incoming, outgoing. Okay, we having the rights to change it. Let's upward arrow, right side arrow, downward arrow. Okay, and I having the rights to close it. If you go into circuit breakers, open, close it. That means that's what the options are there. That's what the options you have fed into the box. Several number of blocks, as a command prompt using the active display box. Okay, active display elements. This is active display elements. But if you go into direct interaction, it's only one. It's only one active elements will be there. Limited active elements are there. If you're going to coming here, what happens? We having n number of active display elements are there. Okay, taken care to control your process as per your requirements. Okay, instead of on off on. If you're going to fuzzy systems, on off, partially off, partially close. It's like that. You're having the provision to increase the blocks, this active display elements in the circuit breakers or wherever you need it. Okay. And if you come into other features, so in navigate interactions, it displays the status. So what happens? We having the boiler 1, boiler 2, boiler 3. It in every boiler. So this is the we can find out. This is a graphical user interface. Okay, which is a graphical user interface. That means it's operator panel, which is ready for human machine interface. In meantime, using graphical user interface, you can diagnose what's happening here. For example, you are having a wall. What's the temperature of the wall? You coming here. What's the boiler temperature? Rest of the boiler. Exhaust valve is ready to release the water exhaust water to some other tank. What's the pressure is coming there? Okay, that's like that. What's the water level in the boiler? That's like that. Each and every process is monitored with the graphical user interface. Let's go to the HMI, okay, and you can find out. See what I said, faceplate. That's here saying faceplate. If you click it, what happens? We are having so many blocks. No sir, I want to change the limit for the corresponding subprocess. Yes, we are in the process to change the limit for corresponding subprocess using the navigate interaction. What the navigate interaction means? We are having so many active display elements are there. Okay, when comparing to the direct interaction, active display elements are more to taken care of the process. Okay, and to face and to keep the process in a safe mode. Okay, actually. And this is not a navigator command extension. There is a difference of the this shows the comparison between the human machine interface and operator interfaces. Human machine interface panel is a embedded OS file, this desktop file. Okay, and it's a command prompt. It is not a command prompt, it is graphical user interface prompt. What I sense is desktop. Okay, we have to make a line by line alphanumerical programming have to be needed for this operator interface. That is desktop based interface. Here entire graphical user interface are required to make to taken care to control the process. Okay. So and less maintenance is done, more maintenance are needed. And well, if you want to change the process, if you want to change your sequence, it's very difficult here, but it is very easy since the graphical user interface. Okay, we can change, change your graphic GUI, graphical user interface in the HMI, and we can check it the process very easily when comparing to the operating interface. Okay, that means what I'm saying that diagnostic is very difficult. Diagnostic is very difficult, but here diagnosis is not needed. Anyway, we have to diagnose. That means you have to check it. If you change the sequence, you are having the right to check it. But what happened? Time taken by the HM panel is very less in compared to the operating interface. We are having the rights to go for adding the more number of active display units here, but it's not possible here. Okay, it's very difficult. That's the difference between human machine interface and operating interface. And compact in size, it takes the n number of space. That means a certain amount of space, and operator have to check it each and everything. Here, it's inbuilt intelligence system is there. Here, inbuilt intelligence system is not there. Even the inbuilt operators having the rights to interface the system. The system will be designed like that. Okay, inbuilt intelligence systems. We just put the processor, what you made a program in the current processor. If not, okay, the operators having the rights to interface system. Here, what happens? The operator, each and everything, the operator have to operate, and the sequence will be executed by the operator only. What's advantages? Yes, as I already said, less space and less power. But if you're going for human machine interface, the cost is too high. Okay, but if you're coming to the disadvantage, the cost is too high. Coming to the advantage, yes, it's it takes less space and power. But what happens? The processing time is high. Okay, we can control the process. If it's oil and gas industries, so you have to control the process as quick as possible if you find any hazardous conditions. Yes, this is the most reliable operator. This is the most reliable HMI and compared to the conventional HMI. Okay, and no operator is needed in comparing to the desktop operator panel. Okay. Operators needed to monitor the n number of processes. But if going desktop process, each and every process is taken care of each and every desktop. So for that, we need each and every operator. So the tedious process. Okay. So and finally it also displayed information. Since we are having active display, more number of active displays into that, we can find out where the problems happen. So if you go in desktop based panel, it's very difficult to find out the problems happen in the wall, second wall in the second turbine 3. But if you come into this side, human motion interface, from the graphical user interface itself, we can find out the problem is happened with respect to so and so wall in the turbine 4 or turbine 3. Very easy as well, because in the block we can find out the temperature is not maintained properly in the boiler. So we can find out what's the interdependent process with respect to the boiler. We can find each and every parameter and find out easily this is a problem happened in that boiler 3. Okay, as operator we are having the right to control that, to taking care of that that parameter with respect to your level. Display disadvantages. Yes, disadvantages. Operator system not clearly display the panoramic view of the large processing view of its limited display area. What I said is exactly correct. If you go into the TV station, if you go into the TV relay station, you can find out so many TVs are there inbuilt before them, and we taken care of each and everything. As like that, what happens here, single desktop will not taken care of around a number of processes. Okay, if it's around 50 or 60%, very easy. If it goes beyond that, single desktop is very difficult to control the process. But what happens? So it sends the graphical user interface. Okay, but if you want to diagnose the problem, you have to click each and every process, and you have to check it each and every active display elements. Active display element, that means block, active display blocks, and find out where the problem is happen. Again, having the rights to tune the problem. But apart from that, if the number of parameters increases respect to process of process, okay, you can go for the n number of desktops. Okay, so 30 process, 50 subprocess will be taken care by one desktop. Okay, another process, okay, another set of process with the different subprocess will be taken care by one HMI. Okay, as like that we can segregate depending upon your process. Yes, what I said is, see, one keyboard mouse with 3 monitors you can monitor. Okay, if you go into the programming software side, the screen will be displayed into 2 off. One, you will make a program. Once you make a program, this side what happens, the thing is going to be happen. So with these changes, you can modify the program. Okay, each and every time it's very difficult to minimize the screen and you go for the screen. The software structure I'm saying. Okay, it can be partially divided into 2. What are programs doing here? Okay, what are programs doing here? We can find out the corresponding modifications here. Some other graphical displays or whatever may be, the value in the form of values or some other alarms or like that. Okay, so yes, multiple monitors with a single display, that's only drawback. That's the thing we are having drawback. So if you're going for this type of setup, we have the investment cost is somewhat too high. Anyway, okay, if you take around the 1000 process, 2000 process, this type of stations only proposed by the design engineer to control the processes. So what you're saying, that enhanced operating stations are employed to overcome the unavailability of the panoramic view. That means a single desktop, if you take care of the 1000 plus, very difficult. So you have to go for multiple monitors based interactions. Okay. So you are saying the alignment equipment is successful multi-monitor graphic control using a single keyboard, single mouse, with a flying cursor that can jump from one screen to the other. Everything is said. So he's having this mouse will have the operator, single operator will taking care of this monitor. That means this around 20 process, and I want to transfer this. I want to change the data from here to here using this mouse. You can also keep it here, as like what I'm keeping here. As immediately I can take this mouse to the other side. This is possible. That's the thing you're saying. Okay, with the flying cursor. In a single mouse, the flying cursor. The single mouse with the operator taking care to control this process, modify this process to modify this process. Okay. Let's see how the system is going on advantage. Instead of three mouses, 3 monitors, a single mouse, single keyboard, the entire process is going to be monitored and controlled. Sometimes what I said, what I said here in the software sector, there are some of the companies are having provision of dividing the screens into 2. Okay, we make a program and we can find out the execution. Okay, as like that. So we are having dual and quad monitors with single mouse and the monitor. See, so for single puzzle will be categorized into 2 monitors, and we can monitor. After conversion of this thing, it comes here again, is going like this. Okay, so if you have the computer, the conversion of this output will be put as input for the third monitors. Okay, as like that, having the dual monitors to taken care. okay, to monitor the process. Coming to display also, we are having 9 matrix display. Okay, 9 monitors. That means so what happens in single monitor. If you go into big process industries, we can find 9 monitors. 1, 2, 3, 4, 5, 6. Each and every monitors. Okay, large screen displays of the process distributed on all the monitors. That's the same thing you're saying. 9 monitors. That's a 3 into 3. Okay, 3 into 3. 9 matrix. Then we can have in 9 monitors. That's the thing. 3 into 3 matrix with the long screen displays, and each and every monitors. You're saying multi monitors. We have 9 monitors at most. Let us convince 9 monitors. 9 monitors will take together n number of processors to monitor and control the process. And somewhat advanced technology also came. Displays with embedded video. Okay. So if you go into any vibration side, I want to analyze the vibration. Yes, it's possible. Okay, you can fuse the video technology, embedded video technology surveillance that, and depending upon the sound acoustics, what's happening with respect to the infrastructure, yes, it's possible to monitor the process happening properly or not. Okay, so since we are having the alphanumeric panels also, okay, you are having the feasibility to interface your camera. Camera systems, live video streams, okay, and probably some other audio systems also to monitor the process. Okay, to monitor the process very clearly and connect for the equipment surveillance for safety and security emissions extra. Okay, so we are having underwater robots. I'm fitting the underwater robots in the water. Okay, what happens? The robots want to monitor the process. So robots transfer the data to Ethernet cable to the operator panel. In meantime, it transfers data. Sometimes what happens, the robot also want to transfer it emits audio signal, it transmits audio signal, again it resists the audio signal, and the audio signal is also transferred to the operator panel, and depending upon the disturbance of the audio signal, what the robot receive, okay, depending upon that also we can find out what's submarines coming, any country submarine is coming, or any other thing, unwanted things crossing like that. As like that, we can predict respect to signals, respect to by the human machine interface (HMI). Okay, that's the thing saying the video stream. Okay, the video stream or audio stream, we can. That's also one of the parameter in the graphical user interface terminal in the HMI. So it's possible. Yes, it's possible. Okay, if you go into the Navy side, yes, they're using the technology. If you go into autonomous robots, the robot is monitoring entire things. And finally, the robot also want to transfer the acoustic sound what's happening in the underground water to monitor the different activities. Okay. So whether PLC used only for process automation? No, it's also used in manufacturing automation. CAD is also used in manufacturing automation. Nowadays, this is also used in manufacturing automation. Then why not is used in the robots? It's possible. Okay. So finally, coming to combined mimic panel operations, so you can find out. Okay, this is the mimic panel. This is a big panel. Okay, 9 into 9 matrix panel with this operating stations. See how it's operating. Or how much? This is so much screens are there. Okay, you can get the big processors and a single mouse. Once you click the mouse with respect to this process, yes, you can monitor the process and they are having the rates to modify the process. Okay, as it's a big panel, and the operator can easily identify what's happening there. If any problems occur, he can able to diagnose the problem and he can work on the problem with this mimic panel and the operation. But most of these panels are proposed in the nuclear power station and the launching for what we can say that you can launching the rockets. Okay, so this type of mimic panels are used in the type of environments. Coming to data logging. So we have 3 types of logging: alarm event logging, trend logging, report logging, and the on-demand logging. So alarm logging means automatically whatever it gives a signal or event. It gives the structure of the event. So what date, what time, what's the category of event, it's a morning or afternoon, what area, and what's a parameter. And it also indicates what's the status of the parameters. That's alarm or event logging. It may be alarm or some other events. Let's put this parameter, let's put this process. That means you can get the data. Data logger means you can observe the data. Okay, respect to the logging, different types of logging: alarm logging, event logging, and second is trend logging. That means respect to plots, respect to graphs. Okay. let's put the graph. That means here trend logging indicates you have to take the graphs, okay, more continuously. Let's put to the time, certain time seconds, certain time. For example, every 5 minutes I want to record the temperature. Is possible? Yes, it's possible. In the let's put the geographical information structure and geographical department, I would record every 5 hours whether what's the waves of the sea. Yes, it's possible. Okay, at what level pressure is coming from the sea is possible every 5 years. Sensors start to work every 5 years automatically, and that transferring to the operator panel, and operator panel can monitor the systems, can monitor how it's working, how the environment is going now. Okay, it can monitor entire things. And going to report logging, it indicates a daily, weekly, always for the minutes or seconds as like that. Okay, coming to on-demand logging, it says that so whether what's the print of the, that means operator can request a log either on display or in print of the current display a print plot extra. Yes, operator can make a request to make find out what's the status going on. Okay, and in the form of display, in the form of taking the printouts, or in the form of plotting the graphs. Okay, these are the 4 types of data loggers. One is alarm event logging to indicate the alarms, or to indicate the structure of the events, or to indicate the entire structure of the parameters, event structure of the parameters. Then the second is trend logging. There is a plot the graph respective to time, respective to certain constraints, and report logging means indicates the date and time and what time it's happened. That's like that the strategy of the process. Okay, and respective to times and the what's happening daily, what's happening weekly, what's happening monthly, as like that. Last one is on-demand logging. Here, what happens? The operator can request the system to give to show the display what's happening there, to show the parameters in the display. If not, he has the right to take the printout in different modes. In whatsoever mode he requested, he can take the right to take the printout. Okay. So, what are things we discussed so far is a human-machine interface. In the human-machine interface, we having operator panels, advanced intelligent operator panels, and the conventional panels, and what are components involved, what are types of interaction, direct interaction, navigator interactions, and probably what other features involved in the navigator interaction. And we also see the difference of human machine interface panels and also conventional panels, and what are the mates and demates. Apart from that, if we are having a number of processes, what type of operators are to be performed to control the process, multi monitors and dual and quad monitors, and probably no number, that means large screen displays. Apart from that, yes, we are also facility to respect to the capturing the images or also recording the audios with respect to the application. And finally, coming to data loggers, as already seen the 4 data loggers. Okay, these are the most important contents. Okay, which cover taken care in the human machine interface. Okay, thank you. Thanks a lot.